Hello and welcome. My name is Joe Fonts. I am a systems engineer with Cato Networks, and today we're going to be talking about queries in the Go language SDK for Cato Networks. All right, let's get into it. All right, let's get into it. So where we want to start off on today's video is at the Cato Go SDK public GitHub URL. So the Cato SDK provides operational simplicity to allow you to leverage the backend Cato GraphQL API. So for those familiar with GraphQL, you can leverage standard GraphQL clients to craft your queries in order to perform queries and mutations, and you can do all that yourself. But in order to simplify some of these operations, we've created the Cato Go SDK. Now, the goal of today's video is to follow up upon the previous one, which was focused on the installation of the Cato Go SDK. And today we're going to be focused on query operations, kind of specifically complex query operations. Now, one of the more complex queries that we can perform is against the Cato XDR API. So for those familiar within Cato Networks, under Home, if you have an XOps license, you get a stories overview and a stories workbench. So these are the XDR stories that are generated within your Cato environment. So this first page, the stories overview, presents information about XDR events that are related in your environment. But specifically, the stories workbench is where we get kind of deeper information. So if we click on any particular story, malware detection, we see that there's a lot of information present. We've got a lot of correlated incidents that have taken place. We've got information based on the source of the expected attack. We've got target actions that have taken place, details, attack distributions, targets, all types of backend information, including the correlated events that are generated in the Cato events feed. All of those are put together into an XDR story so that we can have all of this information correlated together to form it into one overall event. So we get a lot of requests from the field to bring this data into additional destinations for review and reporting by customers. One of the more common destinations is Azure Log Analytics, which is one of the reasons that the Sentinel Connect, the Cato Sentinel Connect module integration allows you to bring this data into Azure Log Analytics. But in today's example, it's going to be, what if we want to leverage the Go language to parse out this data and bring it into wherever it is that you want to put it. So we're going to take all of this data that you see here, and we're going to bring it into a programmable application. So starting off, we can see a lot of what is taking place under the hood of the SDK by looking at the GraphQL queries. So we're going to be using a couple right here. So we're going to list out all stories using XDR stories. And we can see that this is the GraphQL query that's being performed behind the scenes under the hood, so you don't have to craft it yourself. And then from there, we're going to get story details by running this query over here. So this is where the SDK really comes in handy, because instead of having to craft, a query of this length yourself, we can just leverage the SDK, which has done the work for you. So in this example, step one, we're going to list out the stories in a specific timeline. And then step two, we're going to get details for all those stories within the timeline. Now, we don't have to start from scratch here. What we can do is leverage some of the examples. So we're going to look at list XDR stories as the first example. So we're just going to copy this out and put it into our programming environment. So right here, I have an empty directory that I've done. So I'm going to initialize it. Go mod init demo. We've got our modules init over here, and then we're going to go get our github.com, Cato Networks, Cato Go SDK. We're going to download and install the Cato Go SDK module, and then we're going to create our file. Now I already have a environment, a Visual Studio up over here. We're going to paste it in here, and now we can run this file and bring us out all of those XDR story lists. So every single XDR story that we have available. One thing to keep in mind, as we showed in the last video, how to set your public environmental variables. So we will need to provide a Cato API key, a Cato account ID. I've already done that on the back end. And if you would like, reference for how to do that, that is in the intro video previously posted. So I've already done that. So we're going to go run the main.go. This is going to query for the index information for all of the associated XDR stories. We have a limit on stories, so it's 80 stories in this example. So we're doing paging for 80, so it's 80 per page. And then I basically wrote a for loop that just goes through and says, if we're not done, grab the next batch, so that we get all 80, let's see here, all 975 stories in this account in one go over here. So this is all in JSON format. If we wanted to, parse it, we could send it off to a file, we could pass it off to JQ, and this will give us all of the data associated here. Now, in our example, we probably don't need every single XDR story that's been available. So the first thing we're going to do is we're going to filter the input. We're going to say that we only want, for instance, the last 24 hours. So in this example, we're going to create an additional entry for the story data. And this needs to be a pointer over here. For the types, we're looking at time frame as the option. So we're going to look at time frame, which is of type. Time frame predicate. So we're going to create a pointer over here. And then we are going to say, what is the time that we're going to leverage? So we're going to look for T-1 day. You may not remember the exact input types that you're going to be leveraging here. So an easy thing to do is just go over to the Cato API Explorer. By default, it processes the schema as these things come up. And so we can get examples from the API Explorer, which was illustrated in videos by Brian Anderson, our field CTO. So if we want to get a list of time frames that are possible, we can see, oh, look, there's an option here for previous one day, which is this string value, last.p1d. So we're going to put that in here, last.p1d. And so now we should get groups of 80 per page, which are all collated at the end over here for all of the XDR events that have taken place in the past one day. So if we go back to here, we're going to see how many stories we actually get. So it turns out in the past day, only 10 of those stories have been generated / updated in the past one day. So we've already whittled it down to 10 stories from 975. Now, the next step we want to do is to get details on all of those particular stories. So we will leverage an additional example over here. If we go back to the Cato SDK, we can run get XDR story. So if we look at the example here, we see that we're looking for a story ID, optional incident ID, and we're going to pass it to the Cato XDR story call. So we're going to grab this real quick, the Cato XDR story call, and we're going to put that into here. So we don't want to print out everything. We're just going to print out some of the stuff. And so we want to grab all incidents within a story, which is why we're setting that to nil. Within this result, so we've got our query result JSON that's being set over there, initial query result, which is the marshalling of that. We are going to say for key and value in a range of query result dot story items, we are going to, let's first print it. So we've got our index, which is a decimal integer. We've got our story ID, which is a string, a new line. And we are going to use the K, so the key, which is the index, and then V, which is the actual story ID over here for reference over there. I'm going to bring this into the loop. We're going to comment it out and just make sure that everything is working the way that we hope. So we're going to run this again, and we should see a list of indexes and the associated story ID, which we do. So we've got our 10 stories, obviously 0 through 9, starting off at 0, and we've got associated story IDs for each of these. And once again, this reference material is all available in the public GitHub repository. So from here, we can now query all of these individual stories. As you can see, we have a story ID, which is v.id. We're going to pass right into here as a pointer. We've got our query result. We're going to just marshal it as JSON because we'll deal with it later. And now, when we run it, we should see an index print line and then the associated JSON data so that we can pull this information out. And that is what we see. So go for one of the shorter story details here. We've got index 9, that's the story ID, and this is all of that data associated with that story. And we can parse all of those elements individually because Go is a statically typed language. And so each of the elements of this query result has its own individual breakdown. So you can go in and say, oh, I only want the IDs, or I only want the count of incidents that are taking place. However it is that you want to parse and review and then import or export that data, run a report, whatever you want to do. So this is one of the more complex query operations. Having at least an intermediate level of expertise within Go is super helpful here. Some of these query operations do get pretty deeply nested. And so, one of the things that always helps me is just kind of hovering over, looking at, okay, I can put in multiple filters here because this is a slice. Let's add multiple filters. Oh, this story, what can I search on as far as filters? Well, I can search on just the account ID, just a particular incident ID, just particular sources or source IPs, and you can stack these filters on top of each other and not just do something super high level like last one day of operations. So overall, I think this gives you, a good starting point for operating queries within the Cato SDK. As mentioned, this is one of the more complex query operations. There are much simpler query operations where you can just say list all internet firewall rules, WAN network rules, WAN firewall rules. Those, don't require filters at all, or the filters are minimal, search by name, whatever you want. But I wanted to start off with probably the most complex query operation that we have in the platform, just to give you an idea of how this could be illustrated across other API endpoints. So I hope that you guys got something out of this video. I appreciate it. Let us know if you have any questions. We're going to be on the Cato Community Connect portal, and we'll see you on the next video. Thanks.